Good evening. I'm still continuing with geomorphology, the short questions, the ones out of 8 and the ones out of 7. That's what I'm concentrating on now. Okay, various types of drainage patterns. Okay, we are doing drainage patterns now, illustrated by the sketches A to E. Below, choose the sketch that matches the statement or description. So these are the diagrams that we have that shows the different drainage patterns. These are the diagrams that we have that shows the different drainage patterns. Okay, A, B, C, D, and E. Then we have got the descriptions here. This one is your dendritic, this one, is your trellis. This is the mainstream. You can see the short joining at right angle. This is a mountainous or dome-shaped, which means it's a radial. This is your rectangular. You can see this is your deranged. So that's the first thing that you need to do. You need to know the different types of drainage patterns that are shown in the sketch, in the sketch, so that at least it becomes easier for you to link it to the descriptions. Let's see what we have. Activity 4. Let's see what we have. This pattern resembles the spokes of a wheel. Which one resembles the spokes of a wheel? You can see is this one, the spokes of a wheel, which means here is what? It's C. This is what resembles the spokes of a wheel. This is what resembles the spokes of a wheel. So you should know the drainage patterns in terms of description, in terms of what they look like, in terms also of the underlying rock. This is what will help you to get more marks in as far as drainage patterns are concerned. So the moment you know how it looks like, you know how to describe it, then it becomes easier. So it resembles the spokes of a wheel, which means this is the one that we are talking about, which is C, which is your radial or your centrifugal. Occurs in areas that has undergone glaciation. That is your deranged. Which one is your deranged? That is E. Develops in areas where there are folded sedimentary rocks, 2.1.3. Folded sedimentary rock, 2.1.3. That is your trellis, which is what? B. Then tributaries join the mainstream at acute angles. That is your dendritic, which is what? A. Then river flow in all directions away from a central high-lying area. 2.1.5. That is your radial or your centrifugal central high-lying area. You can see this high-lying area is a mountain, so which means it's C. Then occurs in areas that have a uniform resistance to erosion. That is your dendritic, which is A. Then forms in areas where there are alternating layers of hard and soft rocks, 2.1.7. That is your trellis, which is B. So what you need to know is the drainage pattern. That is your radial or your centrifugal. This is your deranged. This is your trellis. Okay, this is your rectangular. This is your dendritic. The moment you know how to recognize, how to identify these different drainage patterns, then it makes your life easier. Even to link it to the statement, then it makes it easier. I've taken you through the answers. It resembles spokes of a wheel. This is the one which is radial or centrifugal. Okay, areas that is undergone glaciation, that is your deranged. Develops in areas where there are folded sedimentary rocks, that is your trellis. Tributaries join the mainstream at acute angles. This is your trellis. Your dendritic. Then the river flow in all directions from a central high-lying area. This is high-lying area where you've got the mountain dome shape. That is C. Then occurs in rocks that have a uniform resistant erosion. That is your characteristic of your dendritic. Then form in areas where there are alternate layers of hard and soft rock. That is your trellis. So this is how we do it. Let's move on to the next one. Activity 5. It's looking at river profiles. So that's what we are doing now, river profiles. That is activity 5. So when it comes to this, boys and girls, what you need to understand is how do you identify a graded profile and how do you identify an ungraded profile? Okay, here there is a temporary base level. You understand? There is a temporary base level, you can see, which means at some point we expect these to be removed so that it maintains this concave Okay, this concave slope, that's what we expect for it now to become graded. That's what. So this means this is your ungraded because there's obstructions. There's a lot of nick points. You can also identify it by having a turbulent flow. That's why we are calling it an ungraded profile. We call it an ungraded profile. This is a graded profile. You can see it's smooth concave, which means now the rate of erosion and deposition is in equilibrium. Here you can see there's more erosion as compared to deposition, hence it's not graded, it's ungraded. That's what this is all about. So let's go through it so that we can see what to do. Since we know that this is graded and this is ungraded profile, okay? This is graded profile, okay? How do we find this is a concave profile, which means the rate of erosion and deposition is in equilibrium. Here you can see there's more of erosion. That's why we have got a lot of nick points along the profile. We have a lot of nick points along the profile. You can see also the type of flow that we have here is turbulent, which shows that there's a lot of nick points along the profile. This is ungraded, this is graded. So once you know how to identify the graded and ungraded, we have also said that there's a temporal base level. As you can see marked by this, that's a temporal base level, which means at some point as the process of grading, river grading takes place, which means this will be removed, and when the rate of erosion and deposition is in equilibrium, that's when it will maintain this graded profile. Let's go through it now. Which of the profiles is graded profile? You can see there is B. I've already told you. Which profile is dominated by either erosion or deposition? Either erosion or deposition, which means here nothing is in equilibrium. It's dominated by either erosion or deposition, which means what we have here, that is our A, okay? Which means these two are not in equilibrium. That's why we take either or. Okay. Then which profile shows evidence of turbulent flow of water? That is your A. As you can see here, it's not smooth, it's uneven. Then which profile has a balance between erosion and deposition? That becomes your B, because now it's concave. It shows you that the rate of deposition and erosion is in equilibrium. Which profile will have a temporal base level? That is 2.2.5. That is your A. This is your temporal base level showed by this dotted line, okay? Which means there's a lot of obstructions along the profile. So a profile which has temporal base level, this is your ungraded profile, which is A. Which profile shows evidence of headward erosion? 2.2.6. It is still A. Remember, headward erosion can be forward or backward. Where we have got a waterfall, let's assume here, which means it cut backs, it's erode back, that's backward erosion. So that's a form of headward erosion. What does headward erosion do? It increases the length of the river. It can be backward or forward. So which shows evidence of headward erosion? That is your A. Then which profile has less erosion? Which profile has less erosion? You can see which profile has less erosion. This one has more erosion. That's why you can see with a lot of nick points, which means your answer there is what? Is B. That is your answer. It's what? It's B. Let's move on to the next question. That has got short questions. Like I said today, I'm only dealing with the short questions. The long questions, I'll do them tomorrow. I'm dealing with the one that are out of 7 and out of 8. So we are moving on now to activity 12. We are moving on now to activity 12, which also has short questions. What do we have? Choose the term from column B that matches the statement in column A. Write only the letter Y or Z next to the question numbers 2.2.1 to 2.2.8 in the answer book. So this is what we have. We have got the statements here in column A, then we have got the letter, okay, in column A. I'll call this column B. Let me call this column B because all of them are column A. So what do we have? We are going to read, then we match with the answers that are here, either X, Y, or Z, okay? A process whereby the watershed changes its position due to headward erosion. Obviously, this is your obstruction. This is your abstraction, not abstraction. It's not infiltration. where the river begins or originates, that is your river source. Where the river originates or begins, that is your river source. Forms on the lower course of the river as the river becomes choked with its load. What forms at the lower course of the river? Which means you have got your distributaries, which is a feature of deltas. That's where you have got your distributors. It formed at the lower course of the river, where the river becomes choked with its load. Those are distributors. Why do we call them distributors? Because obviously they stream from the channel towards the mouth of the river. That can be the lake, that can be the sea. They do not rejoin the mainstream. That's why we call them distributors. They just branch out from the mainstream outwards, going towards the mouth. That can be the sea or the lake. They do not rejoin the river. That's why we call them distributors. These are a feature of a delta. Okay, that's why. Then 2.2.4 forms in the lower course of the river when a river enters the ocean, sea, or lake. So this is what you find at the lower course of the river. A rapid, you find it in the upper course of the river. So the correct answer there is delta. This river is in a state of balance between the rate of erosion and the rate of deposition, 2.2.5, which means that is your graded, which means there's a state of equilibrium between your rate of erosion and rate of deposition. This is a graded river, okay? This is a graded river, okay, or a graded profile. Then we have forms as a result of renewed downward erosion in a meandering river. Obviously, what comes to your mind is incised. To incise is just to cut deep, That's how the river becomes rejuvenated. You cannot talk about rejuvenation when we talk about the natural levees. Of course, these are a feature of deposition in the lower course of the river, which means when the river is in flood, there's deposition that takes place on the banks of the river. That's why we end up having the natural levees. So the correct answer there is what? Y, which is incised meanders. It forms as a result of renewed downward erosion in a meandering river, which means there's river rejuvenation that is taking place. It is a feature of river rejuvenation, that is incised meanders. Then the river profile shows the width and the depth of the river channel. The width and the depth of the river channel, that is 2.2.7, which means we are talking about your transverse. We are talking about your transverse, which shows more like the cross-section, That is your transverse, not your longitudinal. Your longitudinal, it shows from the source to the mouth. So the correct answer there is your transverse, okay? Commonly occurs along the upper course of a river because of steeper gradient. So between these two fluvial features, which one do you find in the upper course of the river? That is your waterfall. The meander, you can find it in the middle on the lower course, but the waterfall is the one that you find within the upper course of the river. Waterfall is the one that you find within the upper course of the river. So, boys and girls, this takes us to the end of our short questions. Please go through these questions in preparation for your final exam. Tomorrow, I will do the ones that are out of 15. Today, I was doing only the questions that are out of 7. That is your multiple choice and your match, and some of them where you are asked to choose from the options that are given. Thank you and good night.